Electricity, that is determination of electromotive force and internal resistance of a battery using voltmeter ammeter methods. So this is a circuit. We have this is the battery. From the battery, we have the resistance box, we have the key, we have the ammeter, we have the voltmeter. These ones are the connecting wires. So you connect the circuit from the voltmeter, from the battery to the resistance box, from the resistance box to the ammeter, from the ammeter to the key, from the key to the battery. This is the negative terminal of the battery. This is the positive terminal of the battery. Then you tap the wire from here, connect it to the voltmeter. You connect another one here to this point, from the voltmeter to this point. And after connection, this is a setup circuit. This one now is a circuit. You close the key. When you close the key, the current will begin to flow. You take the initial current and the initial voltmeter reading. Then, when you remove 1 ohm from here, you record the voltmeter ammeter. You take the voltmeter reading and the ammeter reading. So, for a resistance of 1 ohm, what is the current? What is the voltage? For a resistance of 2 ohms, what is the current and what's the voltage? So you continue like that until you get to 5 ohm resistor. So this is a setup of the experiment. Then we plot a graph of V against current and check out what the value is going to be. So that is the experiment. These are the apparatus. As you can see, this is the ammeter. We have the voltmeter. This is the voltmeter. This is the resistance box. We have the key. We have our key here. This is the battery. So this is a battery. Now we have the connecting wires. So you can now come and set up this experiment. Let's see how it works. Connect the wire very well. Connect, tightly connected. What is the value of your current? What is your I naught?
0.84.
Raise it. Your I naught is what?
1.9.
What is the value of your I naught? I naught. Vote. What the 1 ohm resistor?
0.84.
The current, right?
Yes.
What is the voltage?
0.30.
For a resistance of 2 ohms, for a resistance of 2 ohms, what's the value of your current?
0.60. 0.60.
Then what's the value of your voltage?
70.
Of 3 ohms. 0. The value of the current. Voltage. For a resistance of 4 ohms. 0. For your current. What of the voltage? 0. What of the voltage?
What is it?
For a resistance of 1 ohm, we have current of 0.84, and this one voltmeter is 1.3, and so on. This is initial current, this is initial voltage. So we plot a graph of voltage against current. against current. We plot a graph of V on the vertical axis against the current. You know how we take the slope now? How do we take the slope? The maximum here is 0.84. So we count the number of lines. We count the number of lines and divide 0.84 by the number of lines. That is how we take the scale. But for this horizontal one, the maximum here is 1.9. So we count the number of thick lines up to that point and divide 1.9 by that number. That gives us the scale. So this is the nature of the graph. As you can see, the graph is a negative, it has a negative slope. The slope of the graph is change in V over change in I, which is V1 minus V2 over I2 minus I1. By right, so if it is a positive slope, it will be V2 minus V1, I2 minus I1. Since it's a negative slope, that's why we have V1 minus V2. Then V1 is, look at it here, this reading is 1.5. Look at V2, this point here, this broken line to this point is our V2, which is this. I2 is this point here, 0.81. I1 is this point here, and that gives us this. So this minus this is this minus this one will give us this reading. Now, this divided by this will give us minus 0.945 ohm. But what happened here is that this is our slope. Remember that we have from Ohm's law, we have this one that V is equal to, you know, this principle that says V is equal to E plus, okay, E, we have V, E plus, okay, E minus, minus IR. This one here like this. So when I rearrange this formula in this form, that is minus RI plus E. That is the arrangement. So when you plot a graph of this against this, this becomes the slope. The slope is internal resistance, while this one is the intercept on the V-axis. So where this line cut this point here is the intercept, and this point is the E.M.F of the cell. That point is the E.M.F of the cell. Then the slope is equal to internal resistance. That is, the slope is a negative internal resistance. Our slope has a negative value here, which is this. Multiply equal to this. This minus will cancel minus. So our internal resistance is this. We have already determined our internal resistance. Then the intercept is this value here. Look at the intercept here, where this line cut this axis, which is this point. And that will be, we have 2.2, 2.22, 2.24, 2.26. So our E.M.F is, this E here is 2.26 volts. So that is the E.M.F of the cell, and this is the internal resistance. So we have already determined, achieved our M for the experiment. So this is the end of the experiment. Thank you, and we'll continue next time.